Hello dear students, today we are going to start the class with a short test. You have to tell me about the solubility of these compounds, whether the compounds that you see listed on the screen, whether they are soluble or insoluble in water. So the first one is calcium sulfate, potassium nitrate, barium chloride, zinc sulfate, potassium carbonate, sodium bicarbonate, sodium hydroxide and ferric hydroxide. Take your time to answer these questions. Write them down on a piece of paper, because this channel is all about pen and paper, right? So we need a pen and paper in our hands so that we can understand and remember chemistry easily. So did you Google your answers, or did you take out the chart that your teacher would have given in the school, or you saw it from your textbooks? Let's check if your answers are correct. But before we do that, I'm going to introduce to you a small chart. You know that I'm very fond of making charts, right? So here I'm going to introduce to you a small chart that I have prepared in order to help me remember solubility of ionic compounds. So the first step in this is to check the cation. So whenever you have been given a particular salt, you see the cation. What cation do you have? The positive part, the first part of it. I've called them as the friendly fours: lithium, sodium, potassium and ammonium, because their salts are all soluble. They are all soluble. So wherever you see sodium, potassium, ammonium and lithium salt, you know that it is completely soluble, except one case where I've listed over here, lithium phosphate, which is insoluble. Okay, so that's one task done, right? So let's go back to our chart. So look at the list that we've got over here and tell me soluble or insoluble. Potassium, yes. Potassium, yes. Sodium, yes. Sodium hydroxide, yes. Look at that, we've already got 4 of these in place. After checking the cation, now we have to see the anion. So in case our cation is not any of the friendly fours, we go on to the anions whose salts are all soluble. So I've called it as the ABCN group. A for acetate, B for bicarbonate, C for chlorate and N for nitrate, right? So you got it right. A, acetate, bicarbonate, chlorate and nitrates. Salts containing these anions are all soluble. So would you like to go back to your list and tick another set of soluble salts? So let's quickly go through the anions. So I've got a sulfate, chloride. No, we're talking about chlorates over here. What are chlorates? Chlorates are compounds with the ClO3 negative group, right? So that is not a chlorate. Then sulfate, no. We can't tick off any of these. So let's continue with our chart. Okay. The next set is what I've called as the S8 group. That means X stands for the halogen and S8 actually it's the halogens and the sulfates, right? Because we're going to talk about sulfides also later on. To distinguish it, I've written it as XSATE group. That means these are, so the halides and these sulfates are generally soluble, but there are exceptions. What are the exceptions in the case of halides? Chlorides, bromides, iodides. So these are the halides we are talking about. Out of these, silver halide, lead halide and mercuric halides, these are insoluble, right? These are not soluble in water. By the way, yes, this solubility is all about aqueous solutions, right? So these are insoluble. Which three halides? So we have over here AgPbHg. AgPbHg halides are insoluble. Amongst the sulfates, again AgPbHg, they are the same. Apart from that, barium, calcium and strontium sulfates are also insoluble. So if I say BaSO4, soluble, insoluble, it's insoluble. Silver sulfate, Ag2SO4, soluble, insoluble, it will be insoluble. PbSO4, soluble, insoluble, insoluble. What about PbCl2, soluble, insoluble? Think about it. Yes, again it will be insoluble, right? So again go back to the list that we have and tick off some of the compounds. Go ahead now. Calcium sulfate, yes, sulfate, barium, calcium, strontium. Remember, these are elements of group 2. These are the alkali metals, right? Alkali metals? No, they are alkaline earth metals. Yes, group 2. These are not the alkali. Alkali metals would be group 1. Calcium, strontium, barium, sulfates are insoluble. So let us list down the insoluble one. So I know that this is insoluble. How about barium chloride? Now is barium chloride. So chlorides, which ones are insoluble? Silver, mercury and lead. So what about barium chloride? So yes, this would be soluble. What about zinc sulfate? Zinc sulfate would be soluble. Yes, of course it would be soluble. What about ferric hydroxide? Oh, ferric hydroxide, only one is left. See, we have not even completed half of the chart and we already have ticked off so many compounds from our list. So let's go on to the third part of this chart. Let me make it again a bit neater over here. We come to compounds which are generally insoluble, and here we are taking exceptions. So what I've done is I've put it as green color and pink color. There's a little bit of mismatch over here. These should be green in color because only silver halide, lead halide and mercuric halide will be insoluble. Now these ones, the ones that I put in pink or red, howsoever you can see in your screen resolution, these are generally insoluble. What is insoluble? The hypo sidecar group. What is hypo? HY is for hydroxide, so that is how I called it as the hypo group, hydroxides. PO stands for phosphate group. Side, so that's why I said we are going to deal with sulfides and sulfates, so that's why I put it as side. And of course our favorite carbonates, which we come across very often in the laboratory as well. So hypo sidecar, so hydroxides insoluble, phosphates insoluble, sulfides insoluble, carbonates insoluble. What are the exceptions? Look at the green color. Yes, of course, our friendly fours are exceptions here. Amongst the insoluble, we know that lithium, sodium. Can you list the friendly four? Lithium, sodium, potassium and ammonium. These are soluble. Come to hydroxides other than the friendly four, calcium, strontium and barium hydroxides are also soluble. Sparingly soluble sometimes, but yes, they are soluble. And remember, these are generalizations. Solubility also varies with the temperature. Okay, don't forget that. So this chart is just for a quick overview and a quick recall. We know that solubility depends on a number of other factors as well. Phosphates are insoluble except the friendly four. In fact, now we'll call it a friendly 3 because lithium phosphate is insoluble, right? Coming to the side, the sulfide, right? Again, the friendly fours are soluble and calcium, strontium, barium sulfides are sparingly soluble, right? Last is carbonates. Again, the friendly 4 carbonates are soluble. All the other carbonates will be insoluble. That takes us to the last item in this series. What have we got over here? Hydroxide. What are the exceptions in the case of hydroxides? Yes, the friendly 4 hydroxides and calcium, strontium, barium hydroxides are soluble. Recall here, sulfates of calcium, strontium, barium are insoluble, whereas the hydroxides of calcium, strontium, barium are soluble, right? Calcium, barium, strontium are soluble. They are not insoluble as in the case of sulfate. Please make this very clear, because you will find this very helpful while doing qualitative analysis in the laboratory. When you do the salt test and you do the topic of ionic equilibrium, in such cases, and also for writing our ionic equations, right? This concept is very useful. So that brings me to the last compound, ferric hydroxide. What about hydroxides? Yes, this will be insoluble, right? So what do you have to do? You will take this table, draw it on a piece of paper and put it near your study table, near your dining area, or wherever you sit down to study. In fact, make this chart, take a picture of it, and you can make it as a screensaver in your mobile phones. Yes, that's what technology is going to be that is where technology is going to be helpful for us, right? And you observe it just 3 times in a day, and this will be completely embedded in our mind. Isn't it easy? Because this is very helpful in ionic equations. You must be wondering how it is useful. So I'm going to do a quick equation over here. Although we have dealt with the ionic equations in a separate video, I have taken up many examples of how to write ionic equations. A quick recall over here. So barium chloride, now here I've got barium chloride in an aqueous solution. Ammonium sulfate, NH4 whole twice SO4, gives me barium sulfate. Of course, yes, this is also in aqueous. Why aqueous? Because this is soluble in water, right? Now this is where the chart is coming in handy and useful. What about barium sulfate? Look at the sulfates over here. Where do you see sulfates on the chart? Is barium sulfate soluble? No, it is not soluble. So that means it's a solid, right? So S, and then ammonium chloride. Now again, salts of ammonium are soluble. So I'm going to put an aqueous over here. What's the next step in writing an ionic equation? Tell me. I break it down into ions? No, that's not the first step. What's the first step in writing an equation? Ionic equation. Yes, you have to balance it. Balancing is the most important aspect. Again, balancing has been dealt with in a separate video, and I've given enough examples as practice as well. So when we balance it, I will put a 2 over here, right? Are we now balanced? Yes. Now let us break it down into ions. You see, the salts which are in the aqueous form will have ions. So we will have Ba2 positive, 2Cl negative, plus 2NH4 positive, plus sulfate negative, gives me now barium sulfate. I know that it is existing in the form of a solid, so I am not going to write it in the form of ions. And then we write ammonium and chloride. What's the next step? Yes, we cancel the spectator ions. What are spectator ions? Which are just there but are not participating, right? So what are my spectator ions? Those which haven't undergone any change. So 2 chloride, 2 chloride, that's my first spectator ion, right? So cancels out. What about the next one? 2 ammonium, 2 ammonium. Okay, let's cancel that out as well. What are we left with? So we've got Ba2 positive, because my Ba2 positive, which was in an aqueous solution earlier, and sulfate, which was in a soluble form, has got converted into barium sulfate, which is a solid insoluble form, which you get as a white precipitate. Doesn't it make it very easy? Isn't it? Yes, you will also become confident in writing ionic equations when you know this chart, and also when you practice with what? Yes, pen and paper. That is why I am making these videos by writing with hand, so that I also practice with you while teaching. See you in the next video very soon. Take care.